Welcome to Part 2 of Lecture 2.1 on fractions. Let's talk about comparing fractions. It's not always easy to see which fraction is a larger fraction or a smaller fraction when they don't have the same denominator. But if we get them into some form that they have the same denominator, then all we need to do is look at the numerator to see which one is larger and which one is smaller. So for example, if we want to compare these fractions and we want the denominator to be a 24, then we have a better sense of if 5/8, 5/6, 3/4, and 2/3, which one is the largest and which one is the smallest, and to be able to put them in ascending order, small to large. So I'm going to write 8, the 5/8, with the denominator of 24. 8 times 4 is 20. 8 times 3 is 24. 5 times 3 is 15, so that becomes 15 over 24. 5/6, 6 times 4 is 24. 5 times 4 is 20, so the equivalent fraction is 20 over 24. 3/4, 4 times 6 is 24. 3 times 6 is 18, so the equivalent fraction of 3/4 is 18/24. And lastly, 3 times 8 is 24, 2 times 8 is 16, therefore the equivalent fraction of 2/3 is 16/24. Now I can look at the 15, the 20, the 18, and the 16 to see and rank them from high to low, or from small to large. 15/24 is smaller than 16/24, which is smaller than 18/24, which is smaller than 20/24. But the question wasn't asking which of the equivalent fractions list them from small to large. We need to translate it, back to the original fractions we were given. So 5/8, 2/3, 3/4, and 5/5 in that order. Let's try another example. Let's put 3/10, 1/20, 4/25, and 2/5 in ascending order from small to large with the denominator of 100. So 3/10, and I need 100 on the denominator. So 10 times 10 equals 100. So I know I must multiply the numerator by 10 as well. That gives me 30. Okay. 1/20. Again, my denominator is going to have 100 as the denominator. 20 times what gives us 100? Well, 20, 40, 60, 80, 100, 5. 20 times 5 equals 100. What I do to the denominator, I must do to the numerator. So 1 times 5 is 5. 4 over 25. So if I want 25 times what will give me 100? Well, 25, 50, 75, 100, 4. Again, what I do to the denominator, I must do to the numerator. 2/5 equals, well, 5 times 10 would give me 50, so 5 times 20 would give me 100. And 2 times 20 is 40. Now I can see 1/20 is the smallest, and then 4/25, and then 3/10, and last 40 over 100, which would be 2/5. Okay. Find the common denominator. This time we're giving you 100. Rewrite each of the fractions in its equivalent form with 100 as the denominator, and then put them in order from high to low. All living creatures, all living things, people, animals, flowers, plants, trees, all living things contain a small amount of an atom called carbon-14. It's radioactive and it decays at a very particular rate. From the starting amount to get to half of that amount is called the half-life. And the half-life of carbon is 5,600 years. Long time. So an age of an organism can be determined by measuring the fraction of the carbon-14 which is remaining in it after it dies. At the point of death, or even before its death, it has all its carbon-14. It has 100%, it has 1. At 5,600 years, it has half of the carbon-14. At 11,200 years, it has 1/4. 16,800 years since its death, it has 1/8 left. And 22,400 years since its death, it will have 1/16. And graphically, you can see that it declines very rapidly, quickly, in essence, for the 5,000 years. Yes, it's not that quick, but it's still very quickly. And then the last little bit, it keeps getting half, 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 until eventually it does get so small. A question was brought up of, how do I know what was half? Scientists know what organisms have at the point of death. They can measure it. There are plants, there's humans, there are things that they can measure. And then they can go back and measure dinosaurs and take their fossils and measure that and see how old or how long it's been since their death. That's how we get to carbon dating. So just a fun tidbit. That's it for part 2 of lecture 2.1. So until we meet again, be seeing you.